Welcome back. We are on question 6 of paper 2, November 2019 exams. Alright, question 6 is some more trigonometry, and this is the trigonometric graphs that we'll be looking at in this question. Okay, so some of the information they tell us in the diagrams: f of x, that's this one, that's sine x minus 1. And the other one, g of x, is cos 2x. Okay, our drawn interval between negative 90 and 360, we can see that the graphs intersect at A over here, and the point B, this is 360 and negative 1. So we know that value there is negative 1. Alright, that's negative 1. So that means this will be a 1, and we can go on like that. 1, that'll be a 2, etc. So we don't need to go on with that. That's fine. First question, 6.1. Write down the range of f. So the range of f, so this is f's graph, the equation f of x equals sine x minus 1. So what is the range of our normal sine x function? The normal sine x function, so let's just say sine x, for this one we have a range from negative 1 to 1 inclusive. So now all we do is we're subtracting 1 from that. So the actual range we want is from negative 2 to 0, right? So just subtract 1 from each of these values. That's it. That's our range for sine x minus 1. Question 6.2. 6.2. Write down the values of x in the interval between negative 90 and 360, so this whole graph, for which f is decreasing. So that we can just look at on the graph. We can see where is f decreasing, so it's from there all the way to there, right? There it's decreasing. Here it's increasing, here it's increasing. So it's decreasing from 90 to 270. So from 90 to 270. And is the 90 and the 270 included or not? No, because at 90 it is exactly 0, it's flat, the gradient is 0, and at 270 it's exactly flat, so it's not increasing or decreasing at those two values, so we only do between 90 and 270. Good, now we get to question 6.3, and the last question for this question 6. So they tell us P and Q are points on graphs of G and F respectively, such that PQ is parallel to the y-axis. So they're telling us this could be PQ, or this could be PQ. So PQ is something, is the line that goes between these two. So that's PQ, PQ, it can shift, right? It's horizontal line between, a vertical line between those two curves. And they tell us it's between A and B somewhere. So it's all in between here. Now they ask us, determine the value or the values of x for which PQ will be a maximum. So where will the line be the longest? So one option is somewhere there, and that looks pretty long. This looks a little bit shorter. So we have to find out where exactly, for which x value will the line be the longest. Right, so if we look, we see here it's 2. The distance here is 2, because we know that's negative 1, that's positive 1. So that looks pretty big. And it looks like it increases up to about there and then decreases again. But for 6 marks, we cannot just assume that's right. And in this case, it actually won't be right, because the maximum value will be 17 over 8, which is just slightly more than 2. So let's do the algebra. Alright, so we want to see the difference between the two graphs, vertical distance. So between here and here, between A and B, we know that cos 2x is above. So we're going to say cos 2x minus sine x minus 1. So that's the vertical distance between the two. Okay, so let's simplify this a little bit. So cos 2x is the same as, there's 3 options we can write it as. I'm going to change it so we only have sin. So I'm going to say cos 2x is the same as 1 minus 2 sin squared x. And then multiply the negative in here, so minus sin x plus 2. Okay, let's just rearrange. So we get negative 2 sin squared x minus sin x. Sorry, that's not a 2. Let me just get the eraser. That's a 1. That's a 1 there. Now it's a plus 2. 1 plus 1 is 2. Alright, so here is the distance between the two curves. That's our function for the distance, for the line PQ. So this whole thing is equal to PQ, right? Equal to PQ, equal to PQ. And we want to find out where is this a maximum. So what can we see? We see we have a quadratic type of function here. So we can find the turning point of this and then use that as the, because we know in a parabola, a normal parabola, the turning point will be the maximum or the minimum. So if we just find the turning point, we can work from there. So how do we find the turning point? Well, we say the sine x value is equal to negative b over 2a. And in this case, that means sine x is equal to negative 1 over 2 times negative 2. 2 times negative 2. So sine x equals negative a quarter. Negative a quarter. Okay, that means that x for our reference angle will be the arc sine of 1 over 4. And that gives us that x equals 14.48. 14.48. Good, so that is our reference angle. Reference angle. Okay, now we can work from there. So we see, I'm just going to continue writing next to it here. Let's change color a little bit. That, I think it's becoming a little bit too much, all that green. So let's go. We've got a reference angle of 14.48, but we know sine was negative. So now we have to look at which quadrants is sine negative in. Well, that is this quadrant, the 180 plus, and the 360 minus. That's where sine is negative. So we're going to use those two. So we'll have that x will be equal to 180 plus 14.48, or x equals 360 minus 14.48. And we're not looking for a general solution, only between a and b here. So that's between, that's in here, so that's in that part, right? So we're fine. All we need to do is just calculate these values, and we get x equals 194.48, or x equals, let's just write the or down. So or x equals 345.52. So there is our answer. Now, I've got a feeling this question was a little bit difficult for a lot of students writing this exam, but let me know how you found it, and let me know if you used any other methods. As always, it's always interesting to see other people solving things in different ways. Thanks for joining me for question 6. This was a nice, sweet and short one.